Hello everybody, my name is Aristide, and if you've ever struggled with stringy or bubbly prints, then you might be suffering from wet filament. Yes, even PLA. Sit down, get cozy, and let me tell you about my journey if drying your filament is even worth it. I will create a test to compare 4 different drying methods and their print results. So stick around and find out how much of a difference it really makes and which drying method is best for you. In the past, when 3D printing, I would just go with the flow, take what the manufacturer gave me and not think much more about drying. Whether it would print well or not, I would judge the company based off of the result. But all that changed a few months ago. I had ordered a large batch of filament from a company I previously had great experience with, specifically Sunlu. Over 10 kilograms, and I found out that the spools were not properly dried through stringing and horrible bubbling. This led me down a path of how to get the driest filament and if saving this filament is even worth it. First, let's talk about the test methodology I used. My goal here is to stay as unbiased as possible. I used a brand new spool from the 10 kilogram batch I had mentioned previously. I cut my filament into 6 equal pieces. I precisely measured them to be 2 meters long, and for my American friends out there, 5 feet. I did this to ensure all filament is equally wet to reduce the variances in the drying process. Alongside this, I planned to measure the weights before and after the drying. I want to do this with PLA since that's my most commonly used filament, and I see some people arguing on the internet that PLA specifically does not even need drying. Also, we already know that nylon and ABS are hygroscopic, so there's nothing to prove there. But for PLA, how much does it affect the print quality? So, starting the test. The first piece is a control piece that I will do nothing with. The other 5 pieces I will fully submerge in water for 30 minutes. Yes, you heard me. Fully submerged in water. Obviously, this is not a realistic scenario, but I wanted to push the boundaries and see how the worst case would fare. After soaking the filament in water, I dried one piece using the Polydryer, another one using the Sunlu dryer, one on the print bed at 50 degrees Celsius, and for my American friends out there, 120 degrees Fahrenheit, another in the oven at the same temperature, and the last one I just left out in the air. For each piece, I measured the weight before and after drying. But at this scale, sadly, there was no meaningful difference. Every piece was 6 grams exactly before and after drying. But of course, this didn't get me down. Now I wanted to assess the print quality, which is much more important. So first I printed a funnel to see how objects with smooth curves and a less complex geometry do. Between each print, I cleaned the nozzle with a cold pull to make sure the prints are not affected by the previous filament. I thoroughly cleaned the print bed and applied a fresh layer of glue stick on each one to make sure the prints stick well. I also printed a string test and an overhang test to see how more complex geometries would fare, and to determine if some parts might need more drying than others. Let's get printing and find out the results. So the results are in, and they are a bit surprising to say the least. I did not expect that this piece, fresh from the manufacturer's box, would print so badly. Almost as awful as the fully submerged, undried filament sample. As you can see, the string test shows massive differences, with bubbling and stringing all over. And when undried, even the overhangs got worse on the filament. The filament fresh out the pack also showed rough bubbling at the top of the funnel. The stark difference between the string test and the funnel shows how this might not be directly noticeable on prints with smooth curves, and why it's always good to fillet your edges when designing for 3D printing. The fully submerged filament that I just left out in the air for 24 hours did surprisingly well compared to the first contender. But as you can see, there's rough stringing all over the print. The Polydryer and drying your filament on a print bed were the best methods. In fact, I would say drying on the print bed did slightly better, but the difference were minimal. And I assume this is due to the small sample being on a large surface area, and if there would be a bigger filament sample, this would not be the case. The surprising thing is also how well these filaments printed even though I submerged them in water for 30 minutes. So good to know, wet filament can be recovered. For at-home drying methods without buying a dryer, I do think the oven and heat bed are valid options. But I would prefer not to use either for the following reasons. If you're using the heat bed, the printer will be occupied for a very long time, which effectively makes your printer an over-glorified filament dryer. And with an oven, well, first you need an oven that can control the temperature as low as 50 degrees Celsius, or for my American friends out there, 120 degrees Fahrenheit. This is not possible with most consumer ovens, so I think this is already out of the picture by default. As well as you have to watch out and tell your family, otherwise they might end up roasting your filament like a turkey. The Sunlu filament dryer did not perform as well as I expected. There was a lot of stringing, and I think this is because the Sunlu filament dryer doesn't circulate the air as well as the other method. Neither does it have the surface contact that the print bed had to the filament. That being said, I don't want to put this dryer down. It works very well. I have used it in the past. It just might need a little longer drying times. So, in conclusion, I think having an option of drying your filament is a must. I was able to fully dry my messed up Sunlu filament with the Polydryer or even the heat bed from the printer. People usually print PLA for the aesthetics, and for this, bubbling and stringing can just ruin the fun. For me, the tests show that the Polydryer and the print bed have the best results for PLA. So while I don't think you need a filament dryer, I think it is a waste of a 3D printer to dry your filament on it, so I think it is a good investment for the future. Of course, this does not test a wide range of filaments, but it definitely does show that PLA can benefit from drying. And I will personally be drying every new batch of filament before I print in the future. What do you guys think? Is drying your filament worth it? Can you get away without drying? What do you find is the best drying method for your filaments? Let me know in the comments below. And if you liked this video, please like and subscribe. I appreciate you for watching. Have a nice day. Bye.